In this video, counting and number operations will be discussed. Counting is vital because it helps children understand the base 10 system, which includes the numbers from 0 to 9, do number operations, and problem solve, so children learn to count easily and accurately while figuring out the quantity of objects. While counting is important, it is not enough to only learn number concepts. Children need to understand comparison, cardinality, and one-to-one correspondence. There are two types of counting, namely rote counting, where number names are recited from memory, and rational counting, where a number name is matched to an object in a collection. The second type of counting is more engaging and more practical in everyday life. These are the following counting opportunities, namely knowing number name sequence, one-to-one correspondence, cardinality, stability, relative size, making connections between number names, quantities and symbols, counting forwards, backwards, or middle, and base 10 structure. Hence, a wide variety of learning opportunities can be provided in a classroom setting. The big ideas for counting are firstly that counting is used to find out the quantity in a collection. Secondly, it also has rules that apply to any collection. Firstly, counting is used to find out the quantity in a collection. This big idea recognizes counting as related to number sense, where the main purpose of counting is the cardinal use of numbers, which then allows children to use number operation activities or even to do subtracting. Cardinality is understanding that the last number counted represents the group. Children can then move on to using sets during play with the foundational understanding of quantity. Secondly, counting has rules that apply to any collection. This big idea has the following 4 key principles: stable order, one-to-one correspondence, order irrelevance, and cardinality. Stable order refers to always starting from 1 when counting, so if a child has not mastered this principle, he will use random numbers during counting, and this is not just important for number sequence memorization, but each number is bigger than the one that precedes it and smaller than the next. And because the number system is base 10, every number that ends with 9 will go back to 0. Children should be able to count in the correct number sequence from 1 to 10, and 10 comes after 9. One-to-one correspondence happens when children say each number that corresponds to an object in the group. This is a skill that often takes time for children to develop because they may point to different objects during counting. Adults can guide children to point to objects slowly and articulate the number words. Order irrelevance builds on stable order and generalizes one-to-one correspondence. Because no matter which object the counting starts from, the result will remain the same, and the fact that number words do not change the objects themselves but are only used during counting. But then, this affects reality, so when objects are counted, they should be set aside to avoid confusion. So if a child counts the number of friends seated in a circle, it does not matter if the child counts from the left or right. The child will also understand that calling a friend by a number does not mean that it will be their name. Adults should also guide children to set aside counted objects during counting. Cardinality is knowing that the last number used is a quantity of objects, and cardinality serves 2 purposes. Children use numbers to apply to objects, and children use the last number to represent the quantity of objects. While this may be a simple concept as well, it takes a while for young children to understand. Number operations are tools that need a foundation of understanding that every operation tells a story. These operations simply refer to the following mathematical concepts: addition, subtraction, multiplication, and division. The big ideas for number operations are, firstly, that sets can be changed through joining or separating. Secondly, sets are compact using numerosity and are ordered by more than, less than, and equal to. And thirdly, a quantity can be decomposed into equal or unequal parts, and the parts can be composed to form a whole. Firstly, sets can be changed through joining or separating. Sets can change when objects are added or removed, so children need to know the definitions of adding and taking away. And there are strategies like counting all, where a child counts a set of objects from the first object whenever there is a change, and counting on, which is when new objects are added, but the number continues from the last counted object. As children will be more inclined to use the counting on strategy, teachers can provoke thinking and encourage them to use counting on instead. Secondly, sets are compact using numerosity and are ordered by more than, less than, and equal to. Children will naturally know to use visual comparison to tell if a set has more objects, and they use matching, where sets are placed next to each other, with one-to-one correspondence to determine the quantities. And even if the objects vary in size, children know that they are only focusing on the number of objects. So, even if a larger quantity of small erasers is placed next to a small quantity of big erasers, children understand that there are more small erasers. Ordering is about ordinal numbers of first to last or most to fewest. Thus, the order of number sequences tells the relationship between sets, in which sets are then determined whether which has more than, less than, or equal to each other. Ordinal numbers are also how children attribute numbers to quantity, as they use the terms first, second, and third. Thirdly, a quantity can be decomposed into equal or unequal parts, and the parts can be composed to form a whole. The concept of subtracting is required as children learn that there are multiple ways to get a certain quantity, and they can add and subtract automatically. But this differs from rote thinking, as it is an understanding of part or whole relationships. So 10 can be 5 and 5, but also 8 and 2. So what does the role of a teacher look like? A classroom should have mathematically rich resources like tools, materials, and manipulatives, and also utilize space well. A teacher can look at the walls or outdoor areas beyond just the work tables or shelves that typically contain the mathematical activities. Children can use measuring tools to learn math concepts and use materials to count. Teachers can also implement strategies that include intentional lessons and activities, learning centers, or provocations where children's thinking is triggered as the teacher encourages a new direction of play, though the children do not necessarily have to follow the teacher's guidance. This can include the teacher adding mathematical tools for children to use. Therefore, as simple as counting and number operations may seem to adults, these ideas are more relevant and enlightening for children to learn more about the world around them. As always, thank you for watching and I'll see you in the next video.